Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Clemmensen reduction uses zinc amalgam, Zn, Hg, in concentrated hydrochloric acid, HCl, to reduce a carbonyl group, ketone or aldehyde, directly to a methylene, CH2, group. The reaction converts C is equal to O to CH2 without forming an alcohol intermediate. Moving on to the next step. The starting material is 3-nitroacetophenon, acetyl group, COCH 3 at C1 nitro group, NO2 at C3 of benzene ring. Moving on to the next step. The ketone carbonyl, C is equal to O, in the COCH 3 group is reduced to CH2, converting COCH3 into CH2CH3, an ethyl group. The reaction selectively reduces the carbonyl to a methylene under acidic conditions. And for the final step, Clemmensen reduction is carried out under strongly acidic conditions, HCl, but the zinc amalgam selectively reduces the carbonyl. However, in some contexts ZnHCl can also reduce nitro groups to amines. In this problem, the given correct answer is C, which shows NH2 instead of NO2, meaning the nitro group is reduced to an amino group under these conditions. ZnHCl can reduce NO2 to NH2. The product has an ethyl group, CH to CH3, at position 1 and an amino group, NH2, at position 3, which corresponds to 3-aminethylbenzene, 1-ethyl, 3-aminobenzene. Why other options fail? A keeps NO2 intact and shows correct reduction of ketone to ethyl, but ignores reduction of nitro group by ZnHCl. B shows an alcohol, secondary alcohol, CH, of CH3, which is not the product of Clemmensen reduction. Clemmensen goes directly to CH2, bypassing the alcohol. D shows a longer chain alcohol, CH, of CH2CH3, which is incorrect in both the chain length and functional group. Therefore, the correct answer is C. Therefore, the correct answer is option C.